Welcome to the video. Do we have audio? Test, test. Okay. Hello and welcome to the video. Here's the problem we're looking at. It's a manufacturing example. This company is producing steel rods, and the length of those rods are, let's get our pen out. The length of those rods are normally distributed. Oh, still didn't get it. Let's try again. Lengths of the rods are normally distributed with a mean 175.4 centimeters and a standard deviation of 2 centimeters. And for shipment, 19 steel rods are bundled together. So we can think of this 19 in essence as our sample size. N equals 19. Because they're saying find the probability that the average length of rods in a randomly selected bundle of steel rods is less than 170.6. So even notice in that notation here, we're seeing an X bar instead of an X, meaning an average of a sample, or the mean of a sample. So if you got one of those bundles of rods for your company, what's the probability that the average length of the rods in there would be less than 176 centimeters? So let's draw a picture of what we're talking about here. So let's draw out our normal distribution. And let's fill in the given information. It's a normal distribution. The population has mean 175.4, so the sampling distribution of the mean will also be that. The sampling distribution of the mean will have a standard deviation equal to the population standard deviation divided by the square root of the sample size, so 2 over root n. We can fill in our mean, 175.4 here. And now let's look at the value of interest. The value of interest here is 176, so just a hair above that mean, right? It's just a tiny bit above it, 176. And we want to know what's the probability that my sample will be above that. And let's actually think, I drew this really close, but if we look at the standard deviation here, 2 divided by the square root of 19, that value is 0.45. So let me just rewind a little bit and do this drawing a little bit better. I'm going to take out that red line and say this distribution we're looking at really has a mean at 175, a standard deviation of close to a half. So when we get out here, we're close to 176. So 176 is going to actually be, given the scale of this picture, 176 is going to be close to 1 standard deviation away. Because their standard deviation, 2 divided by square root 19, comes out to 0.4588. Not that you need to do this calculation, although it can help you in making an accurate picture. Okay, so we're looking for the probability that the sample mean is less than 176, so we're looking for all the area to the left of that 176, so shade all that in red. And remember what calculator command helps us find area to the left of a value. That's going to be the normal, so we need to know what is this area, because an area tells us a probability. So we can find that area using the normal CDF command. When we use that command, the first thing we enter is the left-hand boundary of the area of interest. So that's going to be negative infinity here for our calculator. That's negative 1 E9. And then the right-hand boundary is 176. The mean is 175.4. And the standard deviation is that 2 divided by the square root of 19. Let's go ahead and put that in our calculator. We're going to do second vars and option 2, normal CDF, and then negative 1 E9, comma, 176, comma, 175.4, comma, and then 2 divided by the square root of 19. And the answer I get there is 0.9045. They wanted the answer rounded to 4 decimal places, so that would be it. If you're turning in your work, you want to include that labeled on your picture, 0.9045, indicating this is about 90% of the area under the normal curve will be less than 176. Oh, yeah, 176. Or in other words, if you're someone buying these bundles of rods, about 90% of the time you should expect the average length of a rod in your bundle to be less than 176 centimeters.